Hello everyone and welcome back to the series of digital logic design or digital electronics. Today we will study binary codes. Before starting binary codes, we are trying to develop a relation between binary signals, circuit elements and the binary digits. We know that the digital system uses signals which have two distinct values, or any binary digit can have two different values, and these values can be either 0 or 1. Similarly, the digital circuit have two stable states which are also represented by 0 or 1. So we can say that for any binary number of n digit, it will require n binary circuit elements, and each circuit element can have a value of 0 or 1. And with this relation, we can use digital systems to represent and manipulate the binary numbers. And this manipulation can be used for representing various discrete set of information. Like any discrete set of information which is distinct among group of quantities can be represented by a binary code. And this binary code will be a pattern of zeros and ones. Now we can say that if we have a binary code of n bit, then this group of n bits can assume 2 power n distinct combinations of ones and zeros, where each combination represents one element of the set of information which is being coded. Now we know that possible combinations are 2 power n, where this combination starts from 0 and ends on 2 power n minus 1. Now if we have a set of 4 elements and we want to make a binary code for them, for this purpose we will use 2 bits, where each element will be assigned one of the following combination, which can be 00, 01, 10 or 11, and each element must be assigned a unique binary bit combination, and no two elements can have the same value, otherwise the code assignment will be ambiguous. Now we know that if we have 2 power n distinct quantities, and for this we can use n bits, which will start from 0 and will end on 2 power n minus 1, where the number of n bits is requirement for minimum number of bits, where we have no restriction on maximum number of bits for binary code. For instance, the 10 decimal digits can be coded with minimum of 4 bits, where for the same 10 digits we can also use 10 bits, and each decimal digit can be assigned a bit combination of 9 zeros and a single one. So for the particular binary code, the digit 6 will be represented as follow. Starting from the left hand side, the bit in 6th position in table will have a value of 1, while all other 9 bits will have a value of 0. So total bits will be 10. Now we know that if we have 2 power n distinct quantities, n bits can be used for a binary code. But if the number of distinct quantities is not a multiple power of 2, then in this case we will have some unassigned bit combination. Now consider 10 decimal digits. For binary code, a minimum of 4 bits are required. But we know that with 4 bits, we can have combinations from 0 to 2 power n minus 1, which in this case will be from 0 to 15, where the 10 base digits are from 0 to 9. So in this case, we will have 10 digits which are used and the remaining 6 digits which are unassigned bit combination. Now we can also achieve different binary codes by arranging the 4 bits into 10 distinct combinations. And these 10 distinct combinations can use 10 decimal digits or any discrete set of information.
Thanks for watching the video and stay connected for more interesting videos.